Alright, let's do another problem here. This is listed as problem 1040, and I think it's 1041 as well. 1040, here, wait a minute. 1040 and 41 in the book. What both of them do is they want you to locate the centroid and then locate or determine the area moment here. So what I'm going to do is, it appears like this radius of 3 inches starts here. So I'm going to say that what we have is tell you what I'll do is I'm going to attempt to, well, I'll just use my hand and do this. So what we have is 3 sections. Do a halfway decent job. Here's one section. Here's the second section. And then here's the third section. So I'll call this 1, this one 2, and this one 3. Now the unique thing about this section, and I'll color it yellow just for the sake of, because I have a yellow marker, is it's a minus. It's taken out of the area. So let's go and find our, what I will do is I'll find our y bar first. Now if I find my x bar, what we're going to find is the x bar itself is equal to 0, because the center of these, the centroid of one, the centroid of the other, and the centroid of the third are all right there on that x equal to 0. So I can just state that right now, and we'll look at that later. So let's find y bar. Well, let's make our special chart here. We have section, I'll put section 1, 2, and 3. I'll find my area of each one. I'll find, and I'll go ahead and do both here. I'll find x bar for each one. Then I'll find y bar for each one. Hang on. Then I'll find I'll find here. I'll find x bar area. Then I'll find y bar area. And then I'll sum down these columns. So the first thing you know is the area of region 1 is going to be pi r of 3 squared, and it's half of that. Area 2 is going to be a 5-inch. Here, I'm going to change marker colors so we can accent things. 5-inch by 6-inch, or 30-inch squared. 3 is going to be, now it's inside this 1 inch here and 1 inch here, so that's 6 brought down from, so that's 6 brought down by 2 gives you 4 inches. So this is 4 inches here. Now this is basically 5 brought down by 2, or 3 inches here. So 3 and 4, 3 times 4 is 12. Okay, let me make sure I got this right. 6, and this is 3 and 3. So let me fill out the pi r squared. So I'll run over here. Pi times 3 squared divided by half of an area is 14.1372. Now we got to find x bar. Oh, guess what? X bar, the distance from the centroid. Now you have to remember, x starts right here. It's 0, 0, and 0. So if I want to fill out this one, it's 0, 0, and 0. So now if I come down and say x bar is equal to sum of the x bar over a times sum of the areas, I don't care what the areas are, but I'll sum them in a second. That just tells you x bar is equal to 0. Let me sum those down here for a second. Now that I've got those, plus 30 plus 12, the value that goes down here is 56.1372. This is the total. Now I've got to locate my y. Okay, hang on just a second. Okay, I copied it out there. Because I need to know something here. What I've got to do is I have an x coordinate that comes up here, and I have a centroid there. 4r over 3 pi is this distance, and this distance is just flat out 6. So, sorry, it's 5. Copied that down wrong. So, it's 5. Now this is for section 1. 5 plus, and I need this 4r over 3 pi. Now unfortunately, this is an equation, and I didn't make myself enough room. So when I carry this over, I'm going to, here, I'll do it this way. 5 plus 4, and then r over 3 pi. That number amounts to simply 4 divided by pi, or what I will do is 1.2732. Whoops, that is 6 point, because you got to add 5 to that. Oop. .2. So this number is 1.2732, 6.2732. That's the distance from the bottom right here to that location. Let's find now the centroid of the second one, and then we're going to go off for the centroid of the third one. It's 5, so that's just 2.5. That was a little bit easier. This one is, well, I have to add 2, because I have to put 2 to get up here. Then I got to add 1.5. So that makes 3.5, right? 2, here, do it like this. 2 plus 1.5 gives me 3.5. Now what I need to do, I need to take this column times that column, gives me that one. Just bear with me while I execute this. 14.1372 times 6.2732 amounts to, hopefully, 88.6855. Then 2.5 times 30, 75. 3.5 times 12. Oops. Uh-oh. Alright, let me fix that. Now, go get myself over to MATLAB. 12 times 3.5, 42. Should be able to add these all up. Plus 75 plus 42, 205. Oops, I'm taking this one out. So what I have to do, okay, big deal here. Since this one is, since this one is being extracted, this now in being used is the incorrect value. Let us use now the correct value, that is 14.1372 plus 30 minus 12, giving me 32.1372. Now let me add these two. Add these two together, subtract this one to give me 88.6855 plus 75 minus 42 gives me 121.6855. Now I need to know, now this one was easy, and I goofed up because this one didn't matter because this is all zeros, but I need to know this, which is 121.6855 divided by 32.1372 equal to hang on, let me make sure. 6855 divided by 32.1372. 3.7, and we'll go ahead and say 3.79 inches. Now we'll use that shortly, but let's go ahead and record these two values. I'm already at 12 minutes, but I need to continue. But I need to record these two values. That is x bar equals 0, y bar equals to 3.79. Then what I'm going to do is continue the problem in solving for the i's. Let's do the hardest one first. Okay, so what I did is I recopied this down here. I may have made it too far, but that's okay. What I will do now is I will recognize what I have to do. I have to come up and deal with section 1 again, section 2, and section 3. Okay, I need to determine the area. That's already done for me, so I'll just copy that down. 14.1372. Then the area there is 30, and the area there is 12. However, I need new columns here to finish solving this out, and my new columns are, I need to know the IX about that section. I'll go ahead and slide it over. I need to know the distance that I need to move about that section, or move that section to. Then I need to be A times D squared, making very careful to square it, not like I did in the last problem. And then I need to do the parallel axis theorem. And then start adding them all up. So the first one, okay, I have to be really careful here, is all right. So we're going to find I about the centroid of this section. And what I'm going to do is I'm going to calculate it here and then write the number down here. So it's pi r to the fourth over 8, which gives you pi. An r on this is 3 to the fourth over 8. Head over and hit MATLAB up. Pi times 3 to the fourth divided by 8. 31.8086. However, this is not, okay, this is, if you look at this, it is IX about that location and IY about that location. So it is not IX bar, but this value IX is 31.8086. So the question is, what is that? What is IX bar in this case? Well, IX, according to the parallel axis theorem, is IX bar plus area times the distance that you moved. So if this is about the X axis right here, you actually move that distance. So IX bar equals to IX minus area times distance squared, or 31.8086 minus pi r squared over 2 times 4 r over 3 pi, and you're squaring it, because zoom in on it, what you're doing is you're actually moving it. It is given to you right here. You're moving it back to this centroid, which is what you should be doing. So we took this equation, took this term, put it on the other side, became a minus, and so this is what is calculated. And this value is equal to, hang on, let's go to MATLAB. I'm going to pause it because it may take too long here. Oh, quick fix. 4r over 3 pi. Fix the distance again. Distance squared. 4r over 3 pi. 4r over 3 pi. Alright, got that fixed. Now I'll go back and pause it. I just noticed that in the middle of calculating. And that distance became 8. I'm sorry, the I became 8.8903. So let's go back and put our 8.8903. Alright, make this a little bit more reasonable as far as size goes. Okay, next I need to find the I of this second member. I bar X of that 2, 1/12, the base of 6, the height of 5 becomes 6 times 5 brought up to the 3 power divided by 2 ends up being 62.5. 62.5, and then the or region 3, 1/12, the base of 4, the height becomes, and I'll just write it down. Check it out. Let's see. 4 times 3 brought up to the 3 power divided by 12 gives you 9. Now we've got to deal with the distances. Okay, and for this, we're going to zoom in. But what we've noticed is, oops, let's put a green dashed line here. Part of it, here it is. This green dashed line is from our 3.79 from before, or was it 3.97? 3.79. As you zoom in one click here, what you realize is I need to go from here down to this point, and from this point to here. This distance is 4r, keep writing it the wrong way, 4r over 3 pi. I'm going to do it that way. That comes from right here, or 4 over pi, or 1.2732. Now this distance right here is 5 inches minus 3.79, or 1.21 inches. So you add this number to that number, you get 2.48 here. .4832. Okay, so we're good there. Okay, the next thing is, how do we find out the distance from here to here? Well, we know this is the 3.79 minus, but we know this distance is 2.5. Gives us a distance of 1.29 right there. Okay. Now the last distance is just straight up. You got 2 right here to this centroid line. You got 3.5. So it's just basically 3.79 minus 3.5, or 0.29. Okay, so what we need to do now, we've got our D's. We need to multiply our areas times our D squared to fill in that column. Let me slide over here, do some quick calculating, and I can fill this out as, okay, 87.1740. The 49, this one is 49.923. And this is 1.0092. So now I've done that, I've got to do this. Okay. I've got to take this column, add to that column, and put in that column. So for the first number, I get, hang on, 8.8903 plus 87.1740, around 96.0643. Okay, do that for the second and third columns. Okay, I did the same thing. 112.423. And then the last one's just 10.0092. Now we have to realize, okay, in our particular case, this one gets X'd out because it's a negative area, so to speak. And now I've got these things in the way. Just move them out of the way there. Go back to the red pen. Okay, so what I need to do is I need to sum down this column or come up with a total here. So bear with me for a moment as I attempt to do this. Or maybe I better pause it. Okay, so when I get all done, I get 198.4781. Some of those digits are probably not accurate, but because it's a truncation, but I get the answer there. And that's what, in fact, is the real answer. Now, if we take this and generate a new chart, what we'll find interesting is, and what I want to do, is I want to generate another chart, and that is for the IY. And what you'll find is there's a lot of simplicity here. And let me generate that chart first, and we'll see why it is so simple. I will do it all in blue. Section 1, 2, and 3. Guess what? The areas are the same. 14.1472, 30, and 12. The IY. Okay, so this is area. So I'm going to have to take a break here and find the IY of each one of these. And here, let's zoom back out. And what you'll find is, okay, and then what I'll have to do is find the distance. Okay, so here's the key. The key here on this one is that all of the centroids go up this axis. So the distance that you move is all zeros. They're already located at the centroid. The centroid is, as it's sort of stated, he puts it right there. It's at the centroid of the composite. Since it's symmetric, each one of them is symmetric about that x-axis. About the y-axis. It actually has a distance of 0. So I really don't care what AD squared is, because there's not going to be any summation. You could just say 0, 0, 0. So then I'll say IX is equal to IX bar plus AD squared. But in fact, they're the same things. Now, let's look at the y here. 1/8 pi r squared. Now, this time the IX for this was about the x equals 0. But this is the other one. So what you get is the original 31.8086. Now, what you end up with here is the 1/12. Now the base. What is the base on this one? The base on this one's 5. and the height is 6. So go to MATLAB. 5 times 6 brought up to the third divided by 12 ends up being 90 right here. So I can just write this down, 31.8086. And I'll talk about that again here in a second. The half circle. The other one you need is 1/12 the base, this time of 3, height of 4. And what you end up with there is 16. So you know it's 16 and 90. So take the third one, knock it out because it is taking away. You get 31.8086 plus 90 minus 16, roughly 105.8086. And that is the wow. Now let's take a look just quickly. I'm going to basically grab that picture again out of the text. Try to get it a little bit bigger. I think I had it fairly decent size there. But let's talk about this semicircular area. Okay, we've solved this problem. We're done with the problem, but I want to make sure there's a complete comprehension here. Okay, so it's first bothersome. It is the only, hang on, I'll take that back. It's not the only, because the quarter circle is done the same way. And this, the circular sector area is done the same way. But let's just take a look at the semicircular area here. So this is I, as we talked about before. This is the I XX. Now, this is the I YY. Sometimes you'll see 2 X's and 2 Y's. Most of the time early on you're just seeing one. But the question is, which one is this? Now, if you look at it, this is in fact, 1/8 pi r to the 4th. And why is that? Well, because if you took, often they do it this way, they'll say a y and a y this way. That's why they'll put 2 y's here. But in fact, if you were going to move a distance x to locate on this centroid, you are already located at the centroid. Here you're not. It's just 1/8 pi r to the 4th. But that actually is not I bar. It is in fact I bar x here. Let's do it this way. Plus the area times the distance squared, which the distance between, here's your centroid, So if you think about it, he's giving you the moment here, the area moment here. You wanted it here. Here is the, if you're finding it here, it is I bar. Here it's not I. It's not I bar, I mean. So the distance you're having to move is that, 4r over 3 pi, and you're having to square that. So in fact, this is the case. 1/8 pi r to the 4th minus, now if you look at this, you get an r squared and r squared here, so you get r to the 4th. It becomes a little bit annoying, but you have a pi under here. You could say that gets squared and it's 16, but it gives you back 8. This gets squared and it's 9. And I think, okay, let me make sure that may be it. Which, if you stare at that enough, it might make some sort of sense, or it might not. And I'm not sure that but I think my equation is correct. But they don't list that in the book. They list it, they give you the IX and IY. It just doesn't happen to be about the centroid. Let's take a look at some of the cases here in the book. Hang on. And let's identify which ones have this and which ones don't. Very annoying, so to speak. Now, here we have that line about centroid. This is not, okay, but I'm not going to give you that one anyway. But here, if we move down a little bit, but you notice this one is symmetric. You know, if I flip the x and y axis, they're symmetric. But neither one of these are, this is not IX bar, and this is not IY bar. And if you go down here, they should identify this, but they don't. Now this one is one of the first ones you recognize. This one is IX bar. This one is IY bar because the axis goes right through the centroid. This one is as well. Axis goes right through the centroid. Oops. And this one doesn't. Oops. Not going to do the triangle anyway. And so it's very important to recognize that. So I think with this I'll call it quits. This was a long enough one.